Okay, so hi guys. I tried doing this problem earlier and I did it wrong, so I have to kind of do it again. So the idea is that we want to find the area bounded by these two curves. Um, one of them I'm gonna call f of x, so this one I'm gonna call f of x, and the blue one I'm gonna call g of x, okay? So the idea is that we want to find the area bounded by these two regions. So like this one and this one. Okay. Now, um, the idea is usually, you know, so we can't obviously, I mean, I don't know if there's a way to do this, like, in the way that you can combine both functions. I mean, like to make it into one whole integral from from those two areas. To do that, I mean there is, but you have to do it in pieces. So basically, you so we're gonna find, so let's see, 1 second. So we're gonna find the area from, so from -2 to 0, right? So let's see. So it's gonna be so um we're gonna do the area, so the integral from, and we're gonna do, here's -2, so that's my first point, and 0 is over here, so x equals 0 is over here. And what I'm gonna do, so it's from -2 to 0, and I'm gonna get the linear function, or I'm sorry, the polynomial function f of x. So here's f of x, so I'm gonna say f of x, and then minus, and then g of x, and then with respect to x, so dx, right? I'm gonna find the area, and usually in calculus, if you have a function and there's like a line, and usually here's a, and say this is b, you have to do the higher function, so you have to do this one minus the lower function, which is the linear function, right? So that's exactly what we're going to do. We're going to find the area from -2 to 0 of f of x minus g of x. F of x being the polynomial function and g of x being the linear function. So we have the integral from -2 to 0 of the following. So it's going to be x cubed plus x squared minus x plus 1, and then minus g of x. So it's going to be x plus 1, and this is all going to be with respect to x, okay? So you're really going to kind of subtract both of them, so you have the area, or the integral from -2 to 0, and you're going to say x cubed plus x squared minus x plus 1. You're going to distribute the negative over here, so minus x minus 1 dx. Okay, so and this is going to be, so we have the integral from -2 to 0 of x cubed plus x squared, negative x, and negative x is negative 2x, and then 1 and negative 1 cancel out. So then this is dx, right? So, that's what this integral is going to be. It's going to be this following, it's going to turn into this following integral. Now, we have to integrate it. So the power rule, the integral of x to the n dx, is x to the n plus 1 over n plus 1 such that n does not equal negative 1. So we have to do x to the 4th over 3 plus 1, which is 4, plus x cubed over 3 minus 2x squared over 2. And this is going to be from negative 2 to 0. So you have to be careful. I made a mistake the first time around. Negative 2 is going to be your A term, and 0 is going to be your B term. So really, this turns into x to the 4th over 4 plus x cubed over 3 minus x squared. Now, it's going to be from negative 2 to 0, which is obviously going to be, and when you have f of x from negative 2 to, or from A to B, right? Oops, sorry. From A to B, this will be f of B minus f of A. Okay. It'll be, so it's going to be the following. So you have f of x equals x to the 4th over 4 plus x cubed over 3 minus x squared. You're going to do f of 0, so f of 0, so f of 0 minus f of negative 2. So f of 0 is obviously 0, so if you plug in 0 for x, you're going to get 0. You can verify that, but because they're all x, you know, it's obviously 0. And then minus f of negative 2. So f of negative 2 is going to be, so you're going to get negative 8 over 3 as for f of negative 2. So you're going to get minus, so it's going to be minus negative 8 over 3. Right. So then this becomes 0 plus 8 over 3, which is just 8 over 3. Right. So that means that the area from negative 2 to 0 is 8 over 3. So that is what this becomes, 8 over 3, right? And now you have to do the area from 0 to 1. Okay, so you have from 0 to 1, so the area from 0 to 1, and it's gonna be of, and you're gonna do now the linear function, so of f of x, or wait, no, g of x, I'm sorry, g of x, and then minus, it's going to be minus f of x, which is the red one, right? So minus f of x. and then all of this dx. So g of x we said was the linear function, which was x plus 1. So this is x plus 1. And then f of x was the polynomial function, which was x cubed plus x squared minus x plus 1. So x cubed. Okay, so now you're going to do the integral from 0 to 1 of the following. So it's going to be x plus 1, and then minus, and then you're going to do x cubed plus x squared minus x plus 1. Okay, and all of this with respect to x. So then it's going to be the integral from 0 to 1 of x plus 1 minus x cubed minus x squared. You're going to distribute the negative. Minus x cubed minus x squared plus x minus 1. And all of this dx. Okay, so this then becomes, and this is, by the way, this is the fundamental theorem of calculus, if you guys don't know. So yeah, so basically, this becomes the integral from 0 to 1, and it's going to be, so we have an x and an x, right? And then we have a negative x cubed, and then we also have a negative x squared, and we have a 1 and a negative 1. So obviously these two cancel out. These two add up, so x and x add up. So we're going to get negative x cubed minus x squared plus 2x, and then dx, right? So we're looking for the area between 0 to 1 of this whole thing. So we're going to do, this is going to be, again, we're going to use the power rule, so x to the n, it's going to be x to the n plus 1 over n plus 1. So we're going to do negative x to the 3 plus 1 over 3 plus 1, minus x to the 2 plus 1 over 2 plus 1, plus 2x to the 1 plus 1 over 1 plus 1. This gives us negative x cubed over 4, or negative x to the 4th over 4, minus x cubed over 3, plus 2x squared over 2. This gives us negative x to the 4th over 4, minus x cubed over 3, plus x squared. And it's going to be from 0 to 1. Okay. So now we're going to do negative the quantity. So this is going to be, so give me 1 second. So the idea is you're going to do f of 1 minus f of 0. So it's the same thing that we've been doing. So we have f of 1, and we're going to evaluate it. So it's going to be negative the quantity 1 to the 4th over 4 minus the quantity 1 cubed over 3 plus the quantity 1 squared. This is negative 1 over 4 minus 1 over 3 plus 1. This is going to be, so you can do like the common denominator. So times 3 here, times 4 here, times 3 here, and times 4 here. Get negative 3 over 12 minus 4 over 12, and then plus, and then 1 is just 12 over 12. This is going to be negative 3 minus 4 plus 12 all over 12, which is really negative 7 plus 12 over 12, which is 8 over, or I'm sorry, 5 over 12. right? So that is the area between, that is the area between 0 and 1 of that, okay? So, basically, so let's see, what you're gonna have is, you're gonna have, so here is 5 over 12, so this area ends up being 5 over 12. Now, the area of the whole thing is going to be the area of the green part plus the area of the orange part. So it's going to be, so the area of the green part was, we said was 8/3. So it's going to be 8/3. And then plus, and then it's going to be 5 over 12, right? So 5 over 12, right? So this is going to be equal to, and if we, obviously, again, we're going to make the denominator equal, so we're going to get 32 over 12 plus 5 over 12. That's going to be 37 over 12. And if you simplify that, let's see. So to the nearest hundredth, it's going to be 3.08. So basically, the total area between these two regions is going to be 37 over 12. So that is going to be the final answer for this problem, guys. If y'all have any questions, please let me know. And also, please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.